The OERSTED program consists of a few major parts: the menu bar on top, the message area, command line, and status bar on the bottom, and the model tree and search on the left side. To perform a simulation using OERSTED, you first need a geometric model of the physical system. This can be obtained by drawing using the built-in geometric model, or by importing geometry built using commercial CAD packages. We will model an electrodynamic levitation device that is based on Lenz's law. To demonstrate the basic setup and analysis features of OERSTED, geometry created elsewhere is imported. You can see an imported geometry summary in the message area. Units are set up from the model tree or in the Utilities menu. Geometry objects can be set for easy labeling and selection. This setup dialog can be opened using the toolbar or the model tree. Left-click the Create button 3 times to create 3 generic objects with random colors, no assigned geometry, and sequential names of Object 1, Object 2, Object 3, etc. Right-click on each of the object names in the list and rename them as Disk, Inner Coil, and Outer Coil. Select the Add Region button to assign object regions on the model to the objects. By default, OERSTED treats models as representing infinitely long structures. For simulating axisymmetric models, go to the Geometry and Solution dialog box under the Physics menu. Change the default 2D setting to Axisymmetric X or Axisymmetric Y, depending upon model orientation. Set the solution type to eddy current. Click the OK button to close the dialog box. Open the Magnetic Settings dialog under the Physics menu. Set the operation mode to harmonic single frequency and the frequency to 60. Click OK to close the dialog. Next, materials are assigned to the model. The material table is opened from the Physics menu. Assign aluminum to the disk object. No material is assigned to the inner coil or outer coil objects. OERSTED assumes background material with permeability of 1 in regions that are not assigned a material. The material properties of the background material can be edited. From the Physics menu, select the Current Source dialog box. Set the value type to Volume Total. Select the Phasor checkbox and deselect the Static and Transient checkboxes. Set the total amperes per turn value to 9100 for 0 degrees. Click the plus button to assign the current source 1 to the outer coil region. The command line will show the prompt to select the regions. Click the outer coil to select it. Move the mouse and right-click to end the selection. Click the OK button to close the dialog box. To assign the current to the inner coil, open the Current Source dialog again. Repeat the previous steps to assign the total amperes per turn value to 18,360 for 180 degrees. The model is now ready to solve, but first outputs will be defined from the Solution menu. In the Define Outputs dialog, click the Add Plot button, select the Arrows tab, and set the plot properties for magnetic field display as shown. Click the New Plot button and then follow the prompts to set the first and second corner points. The interface will return to showing the Define Output dialog, but with one defined plot and showing a green rectangle through the model for the defined plotting plane. Follow the same process to define a contour plot for the current density on the disk region. Set the plot properties and select the disk. The plots can be renamed by double-clicking on the names. In the Measurements tab, click the Add Measurement button to open the Measurement Editor dialog. Select the Amperian force on region as a measurement type, click the Add button, and select the disk object. Right. Click to end the command. Close the Measurement Editor box. Close the Define Output dialog box. From the Solution menu, select Run Solver. When the solver finishes, the Output Manager box will appear. If the plots do not appear, click the Show Step button. We can edit the presentation of contours by right-clicking and selecting the properties. Properties are edited as shown. These settings affect the visual display of the arrows. Click the Apply button to close the dialog. This sample session has introduced basic techniques that you can use to perform OERSTED simulations.